Good afternoon. My name is James Tu. I like to welcome everybody here. This is my third year in the Atlas event. This is for the first time standing only, standing mostly event, maybe by arrangement. uh, but the enthusiasm has been unprecedented. John and Pong, they did a fabulous job organizing people really from around the world. I have been in climate tech, hard tech, about 12, 13 years. And I'm sure you have heard people talk about climate is a distant threat, you know, and its impact is going to be a few percentage of GDP, even in 50 years. And I always said, it depends on where the impact is, right? You don't see it here. Even if the sea level rises 3 meters, you're not going to see huge changes in the Western world. You just can't. You just won't. There's going to be a lot of adaptation happening, but for the majority of the world, they will continue to suffer and suffer more. And the second thing is relevant to today's topic, um, which is hard tech. And I've been in hard tech for 12, 13 years, and before I managed, global capital in diverse sectors. The hard tech is hard. I'm sure everybody here can attest to that. So it will take you longer than you expected, and more money than you expected to accomplish. So you gotta have to start early. And the whole sentence about climate tech investing. And this is probably the single best event when it comes to family office investing in the sector for the whole climate week, because it's so focused on family offices, and it's so focused on climate tech investing. And people here, I'm sure you can connect to great people here. Great people here. That's probably the biggest value. Now, going to the panel, uh, I like everybody to really talk about your business first, as elevator pitch. These are absolutely excellent, outstanding companies. If I were to put them on a planet, they can probably build the next generation civilization. We probably need a solar guy. We but go ahead.
Sure. I'll kick things off. Try to use the best mic skills I've learned. There's a lot of people in here. It's a little loud, but great to see so much enthusiasm. So I'm Derek Bornick. I'm the CFO and co-founder of a company called Electric Hydrogen. We manufacture the world's most powerful and efficient hydrogen electrolyzer. Basically, large devices that take in renewable energy and water, split the water into hydrogen and oxygen. The hydrogen can be used as a substitute for natural gas in many industrial processes. So as a company stage, we're about 350 people. We've raised about $700 million to date. We are currently building the world's largest ESAF plant in Pecos, Texas. It's backed by Brookfield and HSBC, the Finium project, and doing about 100 million of revenue this year. We are currently out fundraising, as I'm sure many companies are. I'll shamelessly admit it. But right now we're seeing a very strong movement towards hydrogen and e-fuels, particularly in Europe and in Asia. And really interested to talk to folks a little bit more about our business.
Thank you, Derek. Warwick.
Sound like it's going. Any clues?
Yeah.
Sure. Right. Hi, everybody. My name is Warwick Matthews. I'm from the UK, CEO of Tokamak Energy. We're a company based in the UK near Oxford, but we have a US subsidiary and a Japanese subsidiary. I want to go quickly to the what is fusion bit and then move us on really quickly, and I'll explain why. What is fusion? Holy grail of energy. All of the amazing benefits without the downside that you would see in nuclear fission, for example. Basically bottling a sun in a machine held in very strong magnetic field here on Earth. Investors in the room will maybe say, wow, that's a really noble purpose. Let's move on to the next person sat here. So I wanted to explain a little bit more about my company, because while we're positioned really well for fusion, we have an incredible team. We routinely take plasma temperature over 100 million degrees Celsius in our own device. We've positioned the company to be a fusion company that makes money near term. And the way we've done that is by taking a technology that we've developed for future fusion devices, which uses a pretty cool material, which is a high temperature superconducting tape. Within this little metal strip I've got here, there is a 2 micron thick deposition of a superconductor. Take that down to about 20, 30 Kelvin, it will transfer 5,000 amps of current through a layer that is 2% the width of a human hair. And that becomes a massive game changer for new technologies. And we're sat here with a great big IP moat, 10 years of experience, and we're already taking that into a range of new markets. They go from science and medical into transportation, and most recently, and maybe what we'll talk about when we get onto AI, is we're in the field of power distribution. Using this amazing material and the robustness that we can bring through years of research into what we believe is the technology to make electrification, Gen AI data centers work. And that's why we've got an exciting story to tell. We are scaling up. On Monday, we announced that we'd acquired a company in the UK, which makes the big machines that wind superconducting cables. We now marry that up with our design capability, and we've got the scale-up story that we want to start in the UK and take global. And we've got the predictions in our data room that we're about to open for our investment round to back that up. We're not raising gigantic capital. We're doing this as capital light as we can, $200 million total, and we'd love to talk more about it. There's me here, but there's Michael Ginsberg here as well, who heads up Tokamak Energy in the US, and it'd be great to have a conversation.
Thank you, Warwick. Jesse?
All right, so I'm going to follow up the nuclear and the hydrogen experts out here. My name is Jessie Lamb. I am a partner at AIM Partners. It is a venture capital fund, and I invest in infrastructure technologies with a climate lens, but I've been also doing this for a very, very long time. This is actually fund number 5 for me. And so I'm here to kind of bring to a little bit of perspective for all of our family offices investors here. Okay, well, some of this stuff you're going to hear is amazing, and it's also incredibly technical. So if you do run a family office, or if you are, someone that has extra funds, how do you invest in something that is this technical? How do you look at due diligence? How do you partner with people so that you really understand the types of businesses that you're investing in, not only the underlying academic technology, but also, okay, how did they go to market, right? Is this something that can be accomplished in less than 20 years, right? And it sounds like that Warwick is saying that his company can. So I'm kind of here to share some of what I've learned as an investor over the years. I started out as a quant on Wall Street for 10 years, and then I started my first venture fund based out of Asia in 2014. And today I spend time between New York and Hong Kong.
Hi, my name is Cristiano Vitti, CEO of a nuclear micro-fission reactor, which I think is not too bad. I think we have still a way to go. And a couple of things that I want to say is, fission is something that has been around for 50 years at least. The technology of the lightweight reactor that we have there is essentially 50 years old. And I guess that was, some sort of being lazy in some sense, not to innovate the technology, the science. But in reality, at the national lab and in the research world, we have done a lot of work in the last 50 years. And so the company, I think that really the message there was, the start of the company was the idea that there was 50 years of technology out there. We can use it. And that was nuclear technology to design a new concept of micronuclear fission reactor. So we think we have it. And a couple of things is simplicity. So we try to get rid of all the engineers in some sense and try to make it so simple that was easy to build, and that was possible due to new materials that actually were not new, but they just used in research but not deployed. That was the idea. And at the same time, we were able to achieve very high temperatures. So nuclear, as a weak point of nuclear, was always not very high temperature to really replace heat industrial application. So the reality is that there is no replacement for natural gas in industrial application. And with this technology, we can push the temperature so high that actually we can do that finally. So this is, in some sense, is an energy producer rather than an electricity producer. The microreactor is small. The first one is going to be 1.2 megawatt, but there is a value in granularity, and the next one is going to be 15 megawatt. So that will be pretty much be able to cover all the needs in terms of industrial, behind the fence, data centers. So it's a huge market, and there is a replacement that is going to happen in between now and the next 30 years. And that the replacement by itself, without considering the growth, is a huge opportunity. Thank you.
Thank you, Chris. Great. Hi, everyone. I'm Nicholas. I'm one of the co-founders and CEO at 12. At 12, we turn CO2 into jet fuel and into the building blocks or chemicals and materials in many of the products that you interact with every day. So to give you some examples, we made the world's first laundry detergent from CO2 with Procter & Gamble. We made the world's first car parts from CO2 with Mercedes-Benz, the world's first sunglasses lenses from CO2 with Pangaea, and the US Air Force was our first customer for our E-Jet fuel. We're at a really exciting point in the company. We've actually been at it for almost 10 years. I met my co-founders in graduate school at Stanford, and we've really had 3 chapters as a company. The first phase was invention mode, so getting this chemistry that splits CO2 apart to work. Phase 2 was scaling, so scaling up that core technology. And now we're in phase 3, which is execution and deployment, which is really about getting these products into the world at scale. So we've got Air Plant 1, which is our first commercial facility. It's in the final phases of construction now, up in Washington State. And that plant will be powering the first regular passenger service on fuel made from CO2 in the United States starting next year on Alaska Airlines. So you'll all be able to take a flight that has over 90% reduction in CO2 emissions. To put that in perspective, that means per mile, the CO2 footprint of flying would be equivalent to taking the tube in London. So it really can transform the way that we relate to aviation. And it'll, in addition to making jet fuel, it'll produce a product called naphtha, which is the basic building block of the petrochemical industry. Forever, it's been made from petroleum. It can now be made from the air. So we make the building blocks for, even the foam in this chair could be made from the air. And that means it's carbon negative on a cradle to gate basis. So for the life of that product, you've actually stored CO2 and it'll have the exact same quality and same supply chain, which makes it easier for customers to switch. We have over $4 billion in multi-year offtake agreements. We've been really fortunate to raise hundreds of millions of dollars in venture capital and project financing, and have some really great customers. So British Airways is our largest customer now. They'll get the fuel after Alaska. And recent momentum too. We actually just last week closed $50 million in new growth capital. There's a little bit of room in the second closing, and so would love to talk to you about how we're building a world made from air, how these products could end up in your everyday lives, and would love to have you on the journey. We've got a great cohort of family office investors already in the company, including Emerson Collective, the Chan Zuckerberg Initiative, the Dolby family, and many others. So it's a really important part of our capital stack is to have mission-aligned long-term family office investors that we then pair along our core financial investors like TPG, as an example, and corporate investors like Coca-Cola. So would love to have you on the journey with us. Looking forward to this panel too. Thank you.
Thank you, Nicholas. So you got an overview about the technologies. It's almost magic. I mean, if you look at the technologies they're developing 10 years back, right? I mean, so I think this is really the beginning of you seeing climate tech being relevant to our daily lives. This is really just the beginning. So I think today's first topic is AI, right? That's what everybody's talking about. So I actually think that AI actually is an accelerator of adoption of the climate technology. And I give you a simple fact. You can see that all the SMR companies are being on the fly. Fission, fusion, all these companies are being bid up on valuations. If you are in a world where fossil fuel don't count, fossil fuel is 91% of global emissions, right? If you're in a world that fossil fuel don't count, you will see a lot more gas turbine, right, being turned on, coal-fired power plant being turned on, and that's not the case. Instead, the world, including the US, despite of the political wind, is pushing zero energy and zero carbon energy. And that is really an accelerator. So I want to pose the question to everybody here that how do you see AI impacting your business in terms of the demand, the marketplace, and how are you leveraging AI to accelerate your development? Maybe we'll start from Derek.
I'll quickly vote on this. So we are an energy consuming technology, not an energy producing technology. So one of the things about AI is certainly it's creating more demand for power, which does put a little bit more pressure on the inputs needed for feedstocks for producing sustainable aviation fuels and other. As Nicholas went through, kind of what his company does, what our technology is produces the hydrogen that goes in to a lot of these products as well. And so as we look at it, it's a little bit of a blessing and a curse. One of the things that we're seeing is it provides more focus on the regions and locations that have the best renewable power that might be best used for producing fuels. A good way to think about it is if you've got a great renewable resource and it's a good location for a data center, you should build a data center there. If you've got a great renewable resource in the middle of nowhere, like Western Australia, that is an excellent location to be producing e-fuels for export. So it's more of a clarifying feature for us as we are a power consuming technology, but something that also is kind of heightening things on the energy security side is also very important. One of the most important uses for hydrogen globally today is the production of ammonia fertilizer. And now, as the world is more focused on scarce resources, food security is something that people are much more focused on. So that's really the impact that we're seeing in our businesses is heightening the fact that power and resources are certainly not limitless. And so you need to be more thoughtful for how you're able to produce them domestically.
Actually, on this particular point, because I think you represent the hydrogen industry, uh, green hydrogen obviously is what the hydrogen industry is talking about in this sort of the gamut of climate tech. How do you see? I mean, you're basically vying for power, right? In your case, in your projects, how are you dealing with that? With vying for power with the AI data centers.
So it's a great question. So if you've got a greenfield site that's got 1,000 megawatts of power available to it, and it's in a prime location, you're going to build the data center there. Our customers are often, oil refineries in Europe that are importing LNG as part of their process. That's not a great location to go put a data center, but it is a decent location for renewables itself. So we're certainly advocates for more power is better, and we really need to be focused on markets that can deliver power at reasonable costs and are good for exports. I think one of the things over the last few years is the green hydrogen is viewed as something that could solve kind of all problems. It's a lot better when you focus on the problems that it's actually very good at. I think that's the same with AI is, going to add demand for all power everywhere. That's not quite the case, right? Solar and wind are the cheapest power on earth, and that's why it's getting built more, but it won't be all locations at once. And I say this, we've got Microsoft and Amazon as investors and us, and they're still excited about what we do, but having to compete a little bit doesn't necessarily hurt. Sometimes it can help refine the business that you're in. And for us, it's probably been a helpful thing.
Thank you. Warwick?
Yeah, I think AI is woven into everything we're doing strategically, really. In the field of fusion energy research, then AI has been a huge enabler to control system development of how you control a plasma in a device, into the field of material discovery, because for durable power stations of the future, you need really advanced shielding material. However, AI really needs fusion as well. And all these data centers, the production of our SAF, production of our hydrogen, have a common denominator, and that's just this relentless thirst for power. And fusion is the perfect answer to that. But there's still work to do to develop it. I mentioned in the introduction with superconductors that they are solving another problem that we have looming. And that is that data centers have processor racks. Those processor racks used to be 15 kilowatts of energy, now 140 kilowatts of energy. NVIDIA's 2027 chips, 1 megawatt of energy for a processor rack. If you push that through a high voltage system, you are massively inefficient and you're creating an enormous amount of heat in your data center, trying to push all that through copper. So we have a technology now to solve that problem for the future on data centers too. So AI is kind of a woven thread.
That's very interesting. So that's you are seeing that kind of push to materialize your market earlier.
Yeah, that's right. Yeah, and not forgetting the issue that we have about this looming drought of copper as we electrify everything. 2035, we're 10 megatons short of copper demands globally. That's the equivalent of 10 California grids per year of copper that we're missing, and we're taking what's out there today for granted, which we can't do either. So in developing this fusion technology, it's a bit like the space race. You are throwing off relevant technologies. We happen to have caught, I think, the most relevant one to be able to make really high field magnets for amazingly efficient power distribution. And that's why we're scaling up into those areas.
Sounds good. Christian, I'll come back to you, Jesse.
All right. So, yes, of course, AI is as two side of the story is that we like AI because we use AI for designing our reactor. Thing that people may not appreciate a lot is the fact that the more we'll be looking to behind the fence generation, we will need AI to balance the grid. Microgrid are very challenging to balance, and so AI with intelligence response essentially is enabler to stabilize the demand profiles, which makes more efficient the utilization of nuclear reactors. Especially for remote application, industrial application, villages, and so on. The other thing is AI is clearly a broadening of the demand. Now, this is something that I get a lot. Is it your reactor a good size for AI data centers? Well, people may not appreciate because the data centers they make the news are only the 1 gigawatt one, but essentially we're going to be seeing a segmentation of the data center market starting from the small one, the edge computational AI, and then there is actually a section of the AI that actually fills in for loss of load in other data centers. So there is a whole market, an whole ecosystem, which has many different sizes. So we will be ranging from few megawatts up to the 1 gigawatt, but essentially it's going to be a pretty flat distribution in terms of the demand. So we are, quite happy with the fact that even with the 15 megawatt, we will be looking to meet demand up to the 300 megawatt, which essentially is going to cover a lot of the market too. So
Actually, you are in the epicenter of this SMR craze
right.
now. That's another topic, right? We'll touch upon later. How do you feel that sort of ground zero,
Sorry?
ground zero of the impact of the AI demand on the SMR industry?
So what you're asking is that if I think that
How do you see the impact of AI on your industry development?
for the moment it's created a huge momentum, and it's funny because everybody said, well, it's a huge momentum, but nuclear is not going to be ready. And then you look to gas, and there is a backlog in natural gas turbines that is actually 3 years out. So we're actually on the same timeline. And the thing that is nice is that AI is not going to be a step increase in the demand, but it's going to be a ramping up curve. So essentially, everybody is going to have a chance to fill in. So it's creating a huge momentum. Maybe someone else will pick the first data centers in terms of could be a gas turbines. Someone is repurposing, repowering all the nuclear power plant, which is also is pushing the regulatory body to move quicker in this respect. So again, the momentum is great, and the opportunity in the market, even if it is not in the next year, is going to be between now and the next 30 years. There will be room for everybody.
Great, Nicholas.
So for AI, I'll talk about the external impact and then the internal impact. I'll start with the internal. So we use AI to accelerate our core technology development. So we use it in our R&D capabilities for making our process more energy efficient. And then we also use it in our operating plants to help optimize the operating conditions, which will increase the amount of yield that we get to the target products like E-Jet, for example. So those are two ways that we use it internally. Externally, I'd echo what Derek says. It's really refined the types of locations that we go after. It's very different than just a few years ago. of the types of locations that make sense for e-fuels, given the competing demand from AI. And it's important, I think, for e-fuel technology or hydrogen technology to be able to operate intermittently. Data centers are not good at doing that, and so that is one of the features that we're seeing. That our ability to kind of turn up and down allows us to access sites that won't be a good fit for AI. And then on the demand side, though, for some of our products, what's interesting, you might not realize that people are building these data centers so quickly that most of the supply chain is actually served by air transport. So we have one customer who flies in components from Asia into Chicago, and then they send it down to Mexico to assemble, and then to the data center site, and that's all on aircraft. And for some of our customers who are looking to reduce their supply chain emissions, we can help them with that with our e-jet fuel. So it's actually growing demand for jet fuel. That could be your new fact about AI.
That's definitely
Just
unexpected.
one comment. So, for example, if you think about the executive order that right now are shortening the timeline to license, I don't know if these orders would have happened without the demand from AI. So, it's really, really a huge momentum.
Yep. Well, definitely. I think if you look at the whole climate tech space, it has transitioned from sort of emission centered to security centered, right? I mean,
Correct.
energy security is now the biggest topic in actually, to your point, fostering and accelerating the development of climate technology. Jesse, I want to get your opinion, share with your inputs on what kind of AI related hardware climate tech opportunities you are seeing out there in the market that are most attractive to you.
Yeah, I mean, I think a lot of the gentlemen here have different types of renewable energies, right? That's the topic of our panel. But how does that fit into the broader AI landscape? I know a lot of my investors, the LPs into my fund, are always asking, like, where should I enter? Where should I invest in AI? Does that mean I need to go invest in OpenAI or X or Anthropic, for example? Or should I be investing in agentic AI? There's lots of venture funds that are popping up doing that. And so my, Shelly Shankar and my kind of thesis at AIM Partners is really, okay, well, what is AI going to look like when it becomes status quo, when it's no longer a revolution, right? So our thought is that AI and more broadly data centers are going to become a utility. It's going to be in your community, just like water and gas, electricity, and most recently fiber optic cables for telecom for access to internet. So that's going to be in your community. It's no longer going to be necessarily massive football fields of data centers in Idaho, in a potato farm, where the land is the cheapest and the electricity is the cheapest. So you can, back in my day, it was like Intel and IBM, and then, it was the crypto mines, and then now it's a whole bunch of generative AI that's being done in all of these data centers. But what are these data centers going to look like in your community, right? You don't want it to pollute your water. You don't want it to spike up your electricity prices, right? We live in maybe some urban areas, maybe suburban areas, but anyway, there's going to be a lot of people there. So what I'm looking at is very much, okay, what can be small enough to fit into our communities? What can be implemented so that it actually fits into where people live, want to live? You're walking around, you're not going to hear a whole bunch of noise. It's not going to influence your quality of life. There's one company that we've invested in called Provocative, which basically builds small modular data centers. And instead of having this HVAC system that it takes up a lot of electricity, whether it's fueled by nuclear fission or fusion, or other types of heat pumps or natural gas turbines or whatnot, they're basically integrating an entire carbon capture system into their HVAC system. So a data center is essentially airflow. It's airflow management, right? So then if they can take the airflow that's coming off of all of these GPUs that are whirling because it's calculating, I don't know, new pictures of your cats that look like anime, then it can kind of go through their DAC system. It captures the carbon dioxide, purifies it, liquefies it, pressurizes it, and then they can sell that as a commodities contract. I used to work on Citigroup's derivatives desk, right? You can definitely do factoring for that kind of commodities contract. And then that airflow goes back into the data center and cools it. So if you think about something that's scaling like AI, but we're actually taking something that is very useful for humanity, for society, and actually having that pulled along, dragged along to scale at that same rate that AI is scaling, your kitty cat photos are scaling, then that's a way that we can actually scale a lot of this climate technologies without making it kind of like fight each other, right? Or being like, oh, this is a make me like feel good type of technology. Like you need it to be something that makes a lot of sense, is very practical, and is going to be adopted at the same rate that we would adopt anything else that makes money in the world. And that's really where private capital is going to kind of come into the equation.
Okay. I think that leads to the next topic, which is financing and investment, right, in this market. I think the past 2 3 years has been tough for the sector in a way because a variety of factors. You know, you got the war attracting, the whole world's attention. You got the high interest rates, a lot of noises. I think we're seeing the beginning of a lower rate right now. It's still early to see, but we still have inflation, so that's another huge topic. For you, how are you? I want to say how are you convincing, but what's your story to provide an exit, a reasonable exit for investors, right? Your story. I mean, as I said in the beginning, hard tech it takes a long time. Nicholas, you've been this for 10 years, right? Everybody has been this for 10 years. If there's a hard tech company, let's say that they started last year and that's for early stage investors to really make a difference. It's 10, 15 years. How do you convince investors? And do you think going public or other exit will be able to provide a better assurance to the investors about their investment not being locked for 7 years, 10 years? All right.
Sure. So I think that there's a lot of questions there. To kind of kick that off, I think that the fundraising environment is definitely much stronger now than it was 12 or 18 months ago, kind of universally. I think particularly in clean tech and climate, that's even more so the case. What we've been really kind of hearing is that this year's kind of been from confusion to clarity. I think the U.S. has been very loud about all the things that it might do. But what's kind of come to pass is, all of the regulation and all of the incentives weren't gutted. You're seeing in Europe that there were laws passed years ago that people were excited about to take effect, and shame on all of us, me included, for thinking that was going to happen quickly. But now the renewable energy directives and RFNBO and whatnot in Europe, renewable fuels from non-biological origins, for those who aren't fully up to speed, those are now being actually implemented and real projects are being built. I think that we're seeing, the 100 megawatt project that we're nearly complete in Texas for that sustainable aviation fuel facility is nearly complete. We're seeing real projects get done. And, as we've worked with our current investors, folks also like BP and Temasek and Rio Tinto and other great folks along those lines, what we're hearing is you have to have a path toward profitability and toward an exit that makes sense. We earlier on in our days could raise money on a PowerPoint and a great idea. And now it's about us showing up and converting our pipeline. I mentioned earlier, we're doing about 100 million of revenue this year and do have a credible path for an exit here in the next couple of years, but not something we're going to rush and go public earlier than needed. To answer that question, I think it's the easiest thing to model in a presentation in Excel to go public, right? It's just easier than looking at large scale acquisition and whatnot, but that doesn't make it true. The way that we like to talk about it is when we've built the business to a strong enough point, it will likely make sense to be capitalized in a different way than we are today. So that means not capitalized by private equity, growth equity, and possibly capitalized either in the public markets or truly to stay private through actual private equity. So your paths kind of are you hopefully kind of go the SpaceX route, or you go public, or you're not successful, or you kind of look at other avenues for a strategic acquisition. I think all of the companies that we're trying to build here are probably going to be quickly a little big for acquisition, except for some of the largest industrial players. So that's a smaller universe, but one that really understands the space. So try to answer a bunch of different questions.
No, that's good. That's a great.
A lot of nuance. Yeah.
I think the acquisition path and being able to actually select the type of investors you deal with, that's a luxury, obviously. And you have to be really focused on making sure your core constituents of investors are buying the story.
Absolutely. If you don't have the support of your current investors and can't go into a next fundraise with that, it's really difficult to add additional capital. And selecting investors is important, and it's always important to raise capital before you need to, so you can be very selective, so you can make sure that your investor syndicate can add more than just capital. Because there's a lot of money floating around. It's important that those investors can do something else to actually advance your commercial business.
Great. Warren?
Sure. So maybe I'll start by saying our original investor base was really ultra high net worth individuals, and we have changed that slightly in our last round in 2023, where we brought in some strategic and financial bigger investors in, still maintaining, those key individuals who we love followed their money as well, which was great to see. But we're starting to change the investor base. How do I see an exit for those very patient investors that we've had? Well, if I was running what I dare call a traditional kind of VC-backed fusion investment plan, that is pretty hard, because you're going billions into the red to come out in the future with the huge success of fusion. We all want that to happen, but for me, that wasn't a sustainable plan, which is why on fusion, we are taking everything that we've got and we're partnering with a growing number of big government programs around the world. That sounds far less sexy in a VC environment. Government, I said the word government, but it brings stability to what we're doing in fusion. It allows us to continue generating powerful IP for a future market. But really, the superconductor ramp up of that business is what's driving about $400 million of revenue by 2030 in a fusion company. And we're dealing with a broad variety of applications. It's not one single shot on goal, from science through to transportation, in water, land, air, space, and we talked about power distribution. We're also partnering across those markets with big, serious blue chip companies that want our technology. And I think kind of the same way, it's good to build a very strong exec team who is going through all the rigor to make you IPO-able in a couple of years' time, because you don't just decide to IPO. But that's just good discipline anyway. I think with the companies we're putting around us in our day-to-day now, and last week we had our partner summit where we bring a lot of those big companies into Oxford and talk about our strategy and how we're working with them together. It's likely to be one of those that becomes acquisitive of us at one point in the future. So by building the superconducting business, by now bringing in a manufacturing company to accelerate that, we're even more of a M&A target for the future, I would say.
I see. Great. Good answer. Jesse, you want to talk about?
I think when I first started my fund in 2014, on purpose, we talked about being an infrastructure tech fund. We didn't say that we were actually a climate fund. And that's because a lot of the things that you're looking at, it overlaps, but it may not be a climate. You're solving an energy problem. You're solving something that's very practical, that is, like I said earlier, woven throughout society today. And so when I'm saying like, oh, okay, if something is that you, actually everything that you guys build, they're all what I would call like deep tech, first of a kind types of technologies. So if you look at it from that particular lens, there's going to be by necessity a longer timeline. And so that has to be that kind of patient capital, right? If you make a very deliberate choice to make an investment in deep tech, you need to have patient capital. This is not something like a wham, bam, this is not a SaaS with some KPIs that you can kind of bang out in 18 months. And those are necessary, and we use lots of those things today. But like that needs to have a different type of an investor discipline. And I don't want to fight that. Just acknowledge it. This is what you're interested in. This is what you think is going to change the world. If that's what your family office, your investment thesis is, build around that, right? What is the strategic capital that's going to help them go to market? What kind of IP are you harvesting along the way so that you can commercialize, even though you haven't necessarily, teleported us to Mars yet, right? Like there's a lot of steps along the way. So I think that that's a really great way to kind of just acknowledge what your thesis is and kind of invest around that.
Sure. I think that's right. Family office is such an important element in the world of climate tech. And I think this is the conference that is making that happen, hopefully globally, and it will happen. Christian, your sector is the hardest.
Yes, I was
Already
thinking
public.
how to answer to this. It's complicated. So let's start with the fact that yes, we have a round open right now. We have a lead, and we were able to get a lead in August, early August. So how we did that, because it was not easy. I mean, we have been talking for a long time, and it's not been easy. So I think that fundamentals is still what helps you to bring in these type of investors. And the reality is that today, any company that has a viable, cost competitive nuclear fission technology, it is worth, just by that fact, it will be worth several billions, probably more in the 10 to 20 billions. And we see the market, right? So you start from the principle that if you have that technology, cost competitive, that is your value. That is going to happen sooner or later. Starting from that, that is the discussion that you have around fundamental. Now, the next question you're asking is, okay, let's say that you can make that point. Now, what is your discussion about exit? Okay, well, reality is that we have our numbers, right? We know that to have the technology proven to that point in which we can say we have a viable fission nuclear cost competitive technology, we need X amount of millions of dollars. And whenever we bring in an investor, we have that discussion. We say, look, that is the number that we need. We are going to be opportunistic. Right now, the market, for example, the public market is very hot for nuclear. You don't need to be in the revenue space. You may actually be 6, 7 years for revenue, and the market is, it will be favorable to you. So I think that we are actually holding a lot of discussion constantly and evaluating, if this moment we enter to the public market, what is our likelihood to achieve that number that will make us a $10 billion company. So we are keeping monitoring and keeping our investors informed on what is the outlook for that pretty much monthly.
Thank you, Nicholas. 2 minutes.
Sure. We're focused on building 12 to be an iconic standalone business. I think going public will be the most likely exit pathway for us. I think it's interesting to see now some data points, though, of energy or energy adjacent companies that are getting rewarded in the public markets that are still early in their commercialization. So I think of Oklo and Joby Aviation as two examples that both have market caps over $15 billion. And that's like a more recent thing. So kind of to your point about like monitoring the markets, I think it is there's potentially a window now for like a great energy company to go public earlier than probably would have been the expectation in the past.
Thank you. Thank you. So we are overtime, double overtime. So thank you very much for every panelist here, and thank you for your time. You can mingle with all the panelists here during the breakout. Thank you.
Thank you.